last math show of the year. It will also be the last time when I make you do nothing for 2 minutes. So let's do that. This will be the last mindfulness moment of the semester. Perhaps you will carry on your own, but I ask that no matter what you are doing, no matter how you feel about this, you stop right now. Take 2 minutes to stop doing what you are doing. So if you're looking at your iPad, stop doing that. And just sit for a second with your eyes closed. Can you do literally nothing? So when you catch your mind wrapping around a thought, can you just step back from that and release it? Over and over again, this is the practice. Dropping the ball. That is a good little rest, my friends. I won't have to do that again until I can count 2. So. All righty, my friends. So, yes, today's the last bit I have for you. I got news for you. So, let's talk about the important details. Our final is a week from today in this room. So next Monday at 10:10 here, you can have an 8.5 by 11-inch note sheet with whatever you want on it, and an integral table, and a derivative table. So you can have 3 things. So notes, note sheet, integral table, which I just posted a new one. So if you look on World Class, there's, I think I printed out a bunch of copies and forgot to bring them. I'll bring them on Wednesday. Integral table and a derivative table. And here's what the final is going to be like. So the final will consist of one problem where you have to find a derivative and the equation of a tangent line. So given y equals f of x, find equation of tangent line at a point. That shouldn't be surprising. So that's like kind of I need to remember what happened this semester. And this is the one thing I want you to remember, how to do this. Wouldn't it be great on your note sheet to have an example to remind you of how to do that? 1, 2, 3, 4. Got my step-by-step process all lined out. So there'll be that. There will also be find a Riemann sum. And so this is like where I give you the n, where you have some function and you have to cut it up into little pieces and then add up the areas of the rectangles. It'll be a very simple one. Find a simple Riemann sum, and then there will be find a definite integral, and there will be no substitution. So this will be basic ones with no substitution. And then there will be find an indefinite integral, using substitution. Now, I'm going to give you the substitution on most of these. So I'm going to tell you, here's the U to use. So we'll give U sub for some, and then there'll be a couple where I don't. And those will be like the most challenging parts. Several where you determine the sub. Okay, so how do you get ready for this exam? Well, there's two things that you need to do. So prep. There's a web workup. I forget what it's called, but it's something like exam prep or final exam prep. It's like it's quite a few problems, like 17 or 18 problems. One of each kind of these things. So I've got the gamut here represented in that. If you do this entire thing, so if 100%, as you come in to take the exam, if you have 100% on this, I will cut you an extra, I'm thinking 10 points toward the exam. You've got a buffer of 10 points. It's like extra credit or something. Check out the condition, 100%. Smartest thing to do, wait till the last minute and try to cram it all in, right? Fuck no. Start today. Start today, 100%. That's not 99%, that's not anything less than freaking every part of this perfect. So if 100% by exam time, you get a point buffer. Because you're not gonna be able to do corrections on the final, right? It's gonna be, no, we're not doing corrections on that. I don't even know how we'd make that work. Then there is a second extra integral practice. Do this first. Then if you're like, this was pretty easy, I want some serious substitution practice, this will be your friend. Everybody got it? This first, then this if time. Get 100% on that before you even mess with this. And then, yeah, that should be it. Oh, yeah, then Wednesday, I'm going to give you a practice final. And I will have solutions. They may or may not be done by the time I hand it out, but I will have solutions and I'll post them so you'll have that well in advance. Practice final. You don't have to work on this because Wednesday and Friday class, I don't have anything to say. Wednesday and Friday are just optional. But if it would be foolish to not come here at least Wednesday. Optimal. That's not the word I wanted. Optional, but recommended. How the hell do you spell recommended?
RECC.
Is it 2 C's?
Yeah.
And then 3 M's?
No.
And then 4, no, I'm just kidding. But recommended strongly. Because I will post this up on World Class and you'll be able to get it. So if you can't make it here for some reason, you're not gonna miss out. Just like, they're basically like office hours, so they'll be in-class office hours. Does this sound good, friends? Yeah? And that practice final is gonna be one of those things where I would recommend maybe holding off on this a little bit and then timing yourself, sit down, give yourself 2 hours to see where you're at in terms of preparation. My final exam will just be a normal exam. So I don't like go, ooh, it's 2 hours. I will double the exam length. No, it'll just be a normal exam that I expect some people will be done with in like 35 minutes. Any questions about any of this? We feel okay? We can do this? Yeah? All right. Great. Let's go. Let's push onward. I actually printed out a copy of the web work, this one, so that we could do a few problems like that, but we're going to work backwards first because I don't feel like we talked about substitution enough at all. So let's do that first. Some more substitution. We're only going to do this, like I said, with indefinite integrals. So there's like a it just avoids this other part that we'll deal with in Calc 2 when I see all this fall in Calc 2. So let's just start with the problem. I want to find the integral of sine of x plus 3x to the 7th power times cosine of x plus 3 dx. So we'll toss some trig in, but the key thing here is this looks terrible. But the goal and the art of this is to make it look nice. And let's talk about it. There's only so many things you need, and that's why I made you a lovely integral table with the only things you'll ever need for the rest of the semester. So let's make a little tiny one over here as we go through integral table. So integral u to the n du equals 1 over n plus 1, u to the n plus 1 plus c, and that's if n is not negative 1. And then let's just stick with these for a bit. That doesn't need it. This is the, when n equals negative 1, you've got 1 over u, and this is the form for that. Okay, so. So you look at your integral and you realize there's only so many things you can do at this stage. Everything's going to turn into one of these. So that's the thing. You go into this with the mindset that whatever he's given me, it's something on that sheet. It just doesn't look like it yet. So out of those two forms, this is a fraction, right? So this is some kind of fraction thing here. I don't see a fraction in my problem. I do see something to a power. I see this parenthesis with a power. So this thing right here looks like, this is the game, something to the n du, because I see this exponent. One of the great rules of thumb in doing this game is I got to figure out what u is, and I'm going to almost always looking for the messiest thing inside of parentheses. So notice here that if I laid this template, imagine it's kind of like this. You got a box here to the end, and then you've got d something. What falls into that box and that power when I put this on top of that? And so this thing right here is going to be this. This is the stuff in that box. So I'm going to let u equal the thing inside that parenthesis, and then I find du. So this is a choice. And then this is determined by choice, determined by my choice. The next step, which is the derivative, that word is choice, good Lord. So here I differentiate, and I get du, derivative of u, equals cosine of x plus 3, and I'm going to keep that in parentheses and tack on dx. So this I just tack on at the end. Now, a couple of ways we can proceed from here. So let's, one thing is I could just notice that this is beautiful and perfect, because if this is u, and this whole thing would be u to the 7th right here, look at this. This is exactly replaceable with du. So this is literally just du right there. So I'm looking for the patterns. I'm trying to match up. I choose u, I find du, and then see if I can find those in this integral. So for this one, I could just immediately go, oh my God, this is just that. take a minute and look at that. Make sure you see that. Because once we've got this, now it just comes down to using the formula. So this is add 1 to the exponent, multiply by 1 over the new exponent. So here n equals 7, right? Add 1 to the exponent, do that, put it on plus c, and then back substitute and I'm done. So this means I go back to the original variable, which was u, it was x, so u is equal to sine of x plus 3x to the 8th power plus c, and I'm good to go. You always want to back substitute. That's an easy thing to forget, but you're good to go that way. So this is, I would like go this route when you kind of understand the process a little bit better. If you're looking for, if you're like, I don't quite understand this process, give me a better way to proceed, here's what you do. So this method here, I would call this the I just see it method. And I can make everything fit. Here's the, I don't know about this shit method. I could write that up here. I don't know about, put the acronym up. I don't know about this shit method. So what you do at this stage is same start. Choose u, find du. Then come up here and we solve for dx. So that means dx is going to equal du over all this stuff here. Cosine of u plus 3. Cosine of x plus 3, sorry. Then replace the dx in the original with this. Replace the u, replace the original sub as well. And what I mean by this is I'm going to take that integral and I'm going to rewrite it. So I called this part u, and so u to the 7th is this part right here. But now I'm going to copy down this part, cosine of x plus 3, and I'm going to replace the dx, which is going to be du over cosine of x plus 3. So check that out, make sure that you're following that, and you might not be yet, and that's okay. You might not know what to ask. We're going to do a bunch of these today. But the next thing to notice is all the x stuff cancels. So at this point, all x stuff must cancel. If not, you might have made a bad choice on u, or you did some bad derivative action. If not, bad u choice or bad derivatives. And then there's other things that this could go bad with, but notice that this just gets me to where I was a while ago. And at this point, doesn't matter how you get here, it's table time. And then back substitute always. You're good to go. No matter how we get there, we get there. All right, so that's kind of like, that's it in a nutshell. Let's take a look at some more problems. Let's back off the trig. I know how to, I wanted to start with the trig so that everything else would feel a little better afterwards. So what about square root of 3x to the 7th plus 2x, and then out here I see 21x to the 6th plus 2 dx. First thing I would do is rewrite that square root. As a power, because that's how we do calculus, right? We never leave roots in their native notation. Okay, so now I have to choose u. At this point, I've got, there's like two things in parentheses, right? Let's just say I made the wrong call first. I was looking at this and I go, okay, well, this is in parentheses. Don't write this down, just follow along, because I gotta tell you, this is the bad choice. And then I do du. So that's gonna be, not even, right? Just that, dx. At this point, I've done some bad stuff here. Like I could call this u, and then here I could solve for dx, but let's do that. So I take this and I go, okay, well dx is gonna be du over 126x to the 5th. So I'm gonna rewrite this whole thing. I got integral, oh, I didn't do anything with this, so God, I hope to hell that cancels. And then this I called u, and then dx was du over 126x to the 5th. Does stuff cancel? Not at all. It's horrible, right? There's nothing going to cancel. There's this and this. There's no canceling. So I made a bad choice. Well, the good news is there's only one other choice that makes any sense if I'm looking inside of parentheses. So this was bad. It's a self-correcting process, which is kind of nice, as long as you understand the process. So we're going to let u be this. Can you finish this up for me here, friends? So let u equal 3x to the 7th plus 2x. I'm going to run to the restroom. I'll be right back. Once you find du, you kind of know you're on the right track because you start seeing things that appear in the integral, right? So the minute I chose this, I wasn't maybe 100% sure, but the minute I saw the du, I was like, oh my God, yeah, I'm seeing that. So that's a sanity check. Am I seeing things that are like that? So here, dx is just going to be du over that. And I do my rewrite of my integral. It's going to be integral u to the 1/2. This dude here times that. Yay. So literally, I'm actually just doing this. And I go to that power up there, I add 1 to the exponent, so that goes to u to the 3/2. Now check this out. You could do this out in front, but that's ugly. That's clunky. Just take the reciprocal and put it out in front. That number out in front, that 1 over n plus 1, is just the reciprocal of the new exponent. So when you have a fraction, doing it like this makes it easier. Plus c. Hell, I'm done now. Back substitute. 2/3. Crazy expression. Oh wait, what was you?
You mean 3x?
Yes, I do. Thank you, sir. Indeed, I do. To the 3/2 plus c. Don't believe you did it right? Take the derivative and check. So the check, take d dx of this thing. Forget the plus c, that's just going to go to 0. So 2/3, chain rule, 3/2 comes out in front. Decrement by 1 times the derivative of the inside. Notice how these cancel, and I get exactly the original expression that's between the integral sign and the dx. So I did it right. Is there anything you'd like to talk about here? All right, well, let's soup it up. Your turn. Integral 1 over the square root 3x plus 5 dx. Go forth. Integrate. It's going to be a little bit more interesting than the previous two. Keep our buddies up over here. Just make sure you did the rewrite properly. That's what you want. So we're not at the fractions yet. No, it looks like a fraction. It's not. Okay. Yeah, beautiful. Keep on cranking. Yep. Beautiful. This time when you solve for dx, it's going to be a little bit more interesting. It's going to introduce something new, a scaling factor. Do the rewrite. And I guess this is what I mean. We're going to let u equal 3x plus 5? Does that sound all right to everybody? Okay, awesome. Oh, got the worst snacks in my bag. get to the right at all in terms of u part? Are we understanding where that 1/3 came from? See that? And if not, let's talk. Because that's really what you're doing this all for, is to try to figure out if there's some factor that needs to be applied to get the right answer once we go to the simple form. Cool. So, wait, who asked me? So you're cool with like letting u be this?
Yeah.
So then in du, this looks good?
Mm-hmm.
So then at this point I solved for dx. Because I know up here, I want to rewrite this whole thing in terms of u. So I knew that I already got that's going to be u. I got to figure out what this dx is in terms of u. So I solved, after I did this, notice I solved for dx, and it's, you just divide both sides by 3. Does that make sense?
Mm-hmm.
Yeah. So dx is 1/3 of du. So when I replace this, I literally just replaced it with 1/3 du. Yeah? Okay, cool. Glad you asked. And then that factor I'm going to pull out in front, because now it's just 1/3 times do the rule from the table. So now I appeal to the table, and I've got a 1/3 that came along for the ride. Add 1 to the exponent, get a positive 1/2. Multiply by the reciprocal of the new exponent. So it's just a 2 out in front. Plus c. And then all together, and I'll stop again and we can talk. It's that, and then back substitute. That's where I'm going. So, happy to talk about this as much as we need, as much as we want. You let me know. Alrighty. Sounds good. I wanted to do, we're good? Yes,
I think
Claire.
I'm confused on the first thing that you wrote on the second column.
Up here?
Yeah.
Okay. Is it just can't read that word, or?
No, I just don't know.
Oh, okay. So let's start. Cool.
Yeah.
Yeah. And you see where the 1/3 came from?
Mm-hmm.
Okay. So now at this point, I've got 1/3 times this formula, and this formula is just that top one over there from the table, with n equals 1/2.
Oh, okay.
So we're at this point, I'm just like, u to the 1/2. So this goes to add 1 to the new exponent, right? That's that divided by my new exponent.
Okay. Thank you.
You cool? Yeah? All right, awesome. Anything else? Flip the bar. Let's do another one. I like that 3x plus 5. Let's stick with that for a minute. Okay, so now this one kind of looks the same, kind of doesn't, because there's no root down here. There's no root, there's no implied parentheses. So notice that when I saw this one, this was like, oh, there's some parentheses stuff going on, and I can rewrite that. This one here, if I was going to rewrite this, just make a little note, it looks like this. And that looks like the forbidden case of this thing, right? Because here it says, I can do this as long as my exponent is at -1, because what's going to happen when you add 1 to this exponent? It's going to go to 0, and then you'd have to divide by 0. You can't do that. That's forbidden. So this tells me it's this form right here. So let me give you some tips. So this is this form. 1/u du, which is also this form. Just put the du on top. So note, no parentheses in the denominator. So actually 2 notes. Note, this is note 2. Note 1 is I've got a fraction. So that right off that sets off alarm bells, like, oh, it could be that thing. Because this is all about fractions. Unless there's parentheses involved, like over there. So there's a fraction, but there is no parentheses, so I'm going to shoot for this. This is a great form to try for. You just let u equal the denominator. There's nothing wrong with this as a first guess when you have a fraction. Let u be the denominator and hope to hell it's that log form. So in this case, I'm going to let u equal 3x plus 5. du is 3 dx. Solve for dx. Dx is 1/3 du. And then I rewrite this whole thing. So this is looking pretty good because it doesn't seem like there's any x variables floating around unaccounted for. So let me put this here. Looks good because there's no unaccounted for x stuff. If there was x stuff that I didn't see between my choice of u and this du, then I would be suspicious that I made the right choice. So here we go through where you do the rewrite. This is 1 over u, and then the dx is 1/3 du. So I'm just literally doing my replacement. Replace that dx with this, replace that. Right? I can do that if I wanted. That's my old dx. Bring that constant out in front. And now go to the table. The whole point of this is to use the table. Back substitute. Done. You don't believe it? Take the derivative. You'll get back the original 1 over 3x plus 5. All right, so let me know if there's anything here to talk about. Get lower so you can see. Do this stretch. That's nice. Yes, sir.
The only thing is the 1/3 in front of the natural log in the back substituted. I don't see that in the integral table in front of the ln, you know?
Oh, yeah, so these tables don't account for the constants that are going to come out in front. So in some ways, Alex, we're going to use this table, but there's going to be all sorts of different numbers that come out in front.
Okay.
Yeah. You should probably expect to have numbers coming out in front. Yeah. All right, let's try another one. Let's try a bunch. Alrighty, friends. Give it a shot. So think of this as more of an algorithm. I want to do this. You see a fraction, right? First thing to try, don't even see parentheses either. So let u equal the bottom. See what happens.
Right on the top.
Because we don't really, well, you can do it, but I don't think it's going to work out well.
But why did you pick the bottom?
Because I'm shooting for that natural log form where the thing I substitute is the denominator. Does that make sense?
Sure.
Yeah. Just sanity check, my friends. that denominator. Give me another one. Oh, shit. Ah, well. You probably got those written down. Can you see that this one's perfect? It's just beautiful, right? Because once I let u be the denominator, and I find what du should be, I see du just sitting right there. And then u is right there. And I literally just have integral du, 1 over u du. Do you see that, Alex?
Sure, because when you multiply by the du, it goes on the top.
Exactly, yeah. And so let me do it so like just doing that subway, yeah. Dx is du over cos x, so that when I do that substitution, I've got cosine of x, the original, came along for the ride, over u, and then my dx became this, and then those guys cancel.
Would that top equation also be equivalent to 1 over sine x times cosine x dx?
Indeed it would be.
Because that's what I was seeing.
Yeah, that's great. Absolutely, yes. 100%.
I just couldn't see that relationship.
Now it's looking good. And then this is just use the chart. Back substitute. Can you do that one? Let me give you a couple others. Might need a new rule over here. That's a new one. We haven't talked about that one yet, but that's the rule over there that you want to use. Notice what is u in that rule? U is the exponent. When I see e stuff, I'm going to shoot for u as the exponent, at least as a first pass. Should be like some thirds and threes coming out as well to the mix. You already got all this done? You need this? Cool. That's great. It's a very tricky one, despite the fact that it doesn't. So I would let you do the thing inside the parentheses. Yeah, so you're making life really painful for yourself. And the minute, so let's actually talk. So like when you did this, right? You came down, you start getting this big old nasty expression, but that's not in here, right? And so that like is like a warning bell that, boy, that D was looking messy, and I don't see anything like that here. I picture it big, get smaller. So yeah, so this is the right pick. Whenever you have something raised to a power, the thing that's being raised is probably you. Does that sound good? Yeah. Beautiful. That makes life better too, right? No chain rule.
Can you equal square root of 1 over x?
We're doing good here, Carl. We're doing good. Yeah, awesome. Good for you. Alright, so we're doing good here. Yeah. Okay. So, what would be some choices for you? Where's the parentheses? So there's some parentheses in here, right? Usually, what's inside the parentheses is going to be our thing. But notice that if u was sine of 3x, I would have u to the 5th. That would be that bottom rule that is now it's bottom rule. It was the first one I had up there before. Anytime I have a power, like just 1 over power, that's negative power, right? So if I had u to the negative 5th, that could be this if u was sine of 3x. Does that, I don't know, I feel like when I was saying that, that kind of sounded a little chunky, but. So, good rule of thumb, I see something raised to a power, let u be the thing that's raised to that power. That's always a good first guess. So then you just try it and see how it starts shaking out. Yeah. I'll be right there, Emma. Good. Two. That looks great. What about this one? I just did this one too. She's still working on it. Good. Good.
Did she get the same one?
Yes.
Yeah. We'll figure it out. Tell me if you have any ideas.
I'm thinking rewrite it, and then the front piece is you. And then,
Oh, it's 1 minus x to the 1/2.
yeah,
We'll see.
that's my initial guess.
Well, give it a shot.
This is so helpful.
So look here, I got parentheses raised to a power. When I see that in an integral, I'm going to pick the thing that's being raised. I'm just going to make that as my first guess. And I understand that you might not be seeing how that's any rule over there at all. But realize that this, so right, you hit u to the 5th, that's actually just u to the negative 5th. Right, so this is okay, this is just like a negative power down here. In fact, if you want, you could rewrite this like this. This is integral sine of 3x to the negative 5th cosine of 3x dx. Right, so now it looks so much more like that bottom rule, right? It looks like that power rule thing. And you just gotta get used to doing that and seeing that. But parentheses almost always mean power rule, almost always. So this is gonna be my u. Now I've gotta find du. And du is gonna be a chain rule thing, so it's the derivative of the outside times derivative of the inside. Tack on my dx. So now check this out. What does du look like? Or when I solve this for dx, I get dx is du over 3 cosine of 3x. Now I'm going to do my rewrite. So this becomes u to the negative 5th. This is there. I hope to hell it cancels. But if I look just fractions of a second ahead, I see it is going to cancel, and I know that this is going to save the day. Dead, dead, Yay. Here's a third that comes out in front. That's 1 over 3, comes out this way. Look at that. Yay. And now I just add 1 to the exponent, so this is going to be 1/3. Add 1 to the exponent, that's u to the -4th. Divide by the new exponent, that's 1 over -4, plus c equals -1/12. U to the -4th plus c, let's back substitute. That is -1/12 sine of 3x to the -4th plus c. Woo! This might take some practice, but that's good, because that's all we're gonna do. Is there anything there that's troublesome or needs clarification? All right, and then that still might be coming. If you ever want to go back, just let me know. They'll be up on the board for a bit. So now I've got e to something. There's just an e to a power. When you see e to some power, this is a good first guess. Lay this template over. If this is what we have, what must u be? Well, u has to be the exponent. So here I'm going to let u equal cosine of 3x and hope for the best. Then du is going to be negative sine of 3x times the derivative of the inside 3 dx. So dx equals du over -3 sine 3x. This looks like good shit, right? Because this sign is going to cancel with that sign. And I'll be left with all u things. So this is integral e to the u sine of 3x times du over -3 sine of 3x. Huzzah. -1/3 comes out in front. Holy smokes, this is just e to the u plus c, back substitute. Lordy, we are happy because this is just e to the cosine of 3x plus c. Easy to check my answer. Chain rule. So I stop, I wait, you tell me, how does this feel? Yeah, Claire, yes.
So where you drew the arrow, is that just substituting the x that you found into the like?
Yes. Yes, ma'am. Yeah, so I'm taking this and I'm saying, here's the things I'm going to substitute under this, what would happen? Yes. Yes.
Clarifying, sorry.
It's okay.
Just clarifying, anything with the eon or just the same exponent,
I'd say for everything we're going to do, yes.
Oh.
That's a good rule of thumb.
Okay.
Calc 2, that's going to be a whole different story.
Okay.
There's going to be lots of new stories in Calc 2. We don't have the time to get too fancy, so I'm not going to expect you to become some kind of master at this process, because that could get really tricky. But that's not what we want. That's not what you need. All right, let's do some more. Endless barrage. Now come check on my friends with their square root thing. Let's just go back. You're easy. No substitution required. Can you remember how to do this shit? Oh, let's at least make life easy. Can you do that? There's no substitution. Just see if you remember. Let's just make sure we still remember how to do other things. The most basic things. Yeah. And then I'm gonna come make some runs here and see how.
I'm confused for it. Okay, can you simplify it? Okay, first of all, can you square it in here?
Yeah.
Can you square-
So
and
this was the right choice.
It's, yeah, this one,
No.
This
This
one.
one? because then you'd have,
So So yeah, but then, now you've got square root of u. Well, how could you possibly rewrite that x in terms of u?
That's what I was thinking. Would you do like u equals u minus 1?
Yeah.
So then it'd be u times negative u plus u.
Yes. Then, that's just powers of u, right? You can distribute.
Oh, because it's
Yes, ma'am.
This is my thought process. I also.
Oh, yes, too painful.
Yeah,
Far too
that was
painful.
a lot.
Yes, so that isn't gonna, that won't ever pan out, I think, because you'll always be introducing a root that's not gonna cancel. What's a simpler guess? Let's go simpler, slower by, yeah, so what would happen if u was just 1 minus x? Yeah, but then, is it possible, so now you've got u to 1 half, you got that delta, could you somehow rewrite that x in terms of u? And I think you can. You know the relationship between u and x.
And if I have a negative one, do what I mean.
Well, what is x in terms of u? You know what u is in terms of.
Oh, okay,
Aha, yeah. Oh, jeez, I don't even know, probably. That's pretty solid. Indeed.
This is where I'm going right now. So
Beautiful, beautiful, yep.
Reverse derivative.
Using the bottom rule, yes, sir, and then evaluate, perfect. How are we doing here?
I don't know why I can't, like, I know everything, I just never used to.
It's okay, it's all right, just relax, you gotta take it easy on yourself. So I would first just rewrite this, may I, is it okay if I write on here? Okay. So, try to make things look better in your mind. Agree with that? So now I've got a power, right, now I actually have that bottom rule. So I can do this, now I just have to take the antiderivative of this and evaluate it 16 form and subtract. Does that make sense? Yeah, okay, awesome.
Oh, because that's a square.
Indeed, yeah. Yeah, I don't know about, oh, yes, that was good. Okay, got it, you hadn't done the integral. Yes, perfect. You just hadn't taken your, I thought you were doing your antiderivative there, but you weren't. Okay, so for this one, there's no substitution on this one because, check this out, I'm sorry, I didn't even just grab that earlier. So check this out, this is integral 4 it's straight up, that bottom rule. See? Yeah, it's much easier. Now you can do the integral power rule,
Basic
then
things,
you're
can you
rocking.
grab like slow
Are we good?
Same base.
6, but something we'll check.
Okay, so you did the same thing. I was like, wait.
But I'm not sure.
Oh, here, sorry, yes.
That's why I'm like. Okay, so then I started that and I already did it.
No, I think you can.
Let's talk through it.
Then I was like, did I do that correctly?
Are you talking about this problem we're doing right now?
Oh, what's 1 half
It's
plus 1?
a funky one.
Or negative
Isn't
1
it
half
be
plus 1?
plus? Yeah, it would be
I don't think so.
the 3 halves.
That's why. Okay, so.
Right?
Yes.
And then from there, you just
So this just looks kind of strange here.
Oh,
but
because
I
you
would
have yours
say
flipped.
this.
Yeah, I just added it to that.
Sorry.
Oh.
Because I have the negative one attached to the
But
B.
this is the first major step, is realizing that, yeah, that's just that. And then there's no substitution needed.
Oh,
Now you
it's-
can actually just use the power
Because I did,
directly
it
in the
basically
bottom.
would be like
And
u
equals negative half.
over negative.
Oh,
You see?
So that's
Yes.
just negative.
Yes,
B.
okay, good.
So I just
There you go.
popped it on the front.
Okay,
Oh, wait, did I miss a
So,
negative? I think I missed a
um,
negative.
the cool thing is,
Yeah, go
if
ahead.
this was the right
I missed a
rewrite, then
negative.
there's some good shit that happened.
This is yeah, I missed this because I
Because
substituted
that's
that in.
under.
It's the
But I'm not
negative.
sure
Right, so let's,
where the
so
negative
square root of
has
x
to
would
go,
be
because
just
that
x to
does
the
affect
positive
like,
1 half
Did you just go?
over
its own.
x to the negative. Yeah. So then let's
parentheses.
That's right. So now we're gonna use the power rule. Add 1 to the exponent.
So
So what's the
then
new
for
exponent?
values,
And that's
I'm just
positive
gonna
and that's
do
negative.
What's negative 1/2 plus 1?
on the outside, and then
Yeah.
differentiate.
I think so.
Yep, positive half.
So that,
And then I multiply by the reciprocal,
is u to the 3/2.
and then I evaluate that for
And then
460.
to this.
Yep, and then forward x and subtract. That's it, does that make sense?
Yeah.
Okay, awesome.
Oh, yeah, cause I just distributed it out. Then the negative.
Yeah, so, notationally, really great. This is gone because, what do you want 12?
What? Where?
Cause I have them two-thirds would be negative.
So,
Wait,
look at the steps here. These
Oh,
limits.
but then
two-thirds would be negative two.
Okay, so here's step 1.
I think
It's actually.
because this is technically a negative, it's technically a 1 or -1, it's
Step
a
one.
-1
Find
constant,
just
hold it out in front.
the antiderivative of that.
I think I see what you're saying.
So I'm just
Wait,
reading this,
so
so
you're
this is
the
the
1/2,
antiderivative.
negative u.
Step
plus
2.
one, so this has to be negative.
Plug,
Once
B
du comes in, it has to be negative.
into
And then, right, so
antiderivative,
you can
And
do
you have
one
the
minus
negatives
plug
x.
A into the antiderivative, and then subtract. Subtract these results. So you're subtracting the limits, they don't get subtracted till they're plugged into this
I
thing.
mean, no, it works.
Okay, so then, let's check this out. So
So then
this
negative-
is
I think
integral
here, you
460
had it, and then you didn't
x
put
to
the negative in
negative
front of this
1/2.
one.
You got that, that's
Oh,
beautiful.
and this one's
There's just
negative.
not that 1/12.
Because that u is negative. Let me, hold on,
And
let
so
me.
now,
read.
this,
one
beautiful, this is so
why
freaking
I
good,
wrote it.
but there's not that out in front.
So it doesn't get confusing.
And there's not that, cause we're done, you actually, this was the antiderivative,
One minus
you
u,
just
so
did
that
that.
is u
Now we're just at,
to the 1/2
1/16.
minus u to the 3/2.
yes ma'am, so that.
So I just have it flipped.
Am
So
I
then,
missing anything?
I think
See,
you might be missing it.
So wait until the very end to do your
Ah, my
subtraction.
genius. Wait.
Does that sound right?
Oh,
Okay, cool,
yes, it
awesome.
is here.
You're welcome.
It's
Cause I was
like
trying to go backwards and
this.
change the time from the.
And that. Yes. Yes. Boom, we killed it.
Yeah, this one.
That's funny. So I need to like organize my notes better. Do you see?
Oh, that's what mine looked like. Yeah.
I gotta process this.
It was for.
It is 4, but you gotta get it, yes, just done the right way, yes, yes. It is 4. Let's talk, questions at all? Oh, silence, nice.
I did the same thing, but on the interval from 2 to 4. And then
Wait,
got
why is the 2 up? Oh, never mind.
Does that make sense? Yeah, because that's 1 over a half, or the reciprocal of the new exponent. Yes?
I was testing the relationship, so instead of doing, I did 4 to 16, but I also did 2 to 4,
Oh,
and I got 2, right?
yeah?
I'm doing bigger numbers because it looks like it's just the bottom number.
That sounds right, but, use the numbers that are given. But, it's cool, I like that you're making up your own problems. That's like a whole new place. Alrighty, if there's no questions, let's just do a couple more. Oh, no, shit, I wouldn't do that to you, sorry. No substitution. Bad man. Sorry. Don't do that. Don't do any of this. This will be chill. And I'll put another one, less chill.
I think I got the first one. Maybe I'm sure. Yeah.
Good work. Oh, so this was average value. So this is like a whole different, this is like find the average value. It involves this process, but there is an extra number out in front. So the thing out in front is just 1 over the width of the interval. You don't need to do that, not unless it says find the average value. Yeah, okay. Good question. We'll make these our last ones for today. What did you end up getting on that last one? Yeah, can you simplify? Yeah, that one's, yeah. Can you simplify? Yes, come on.
Oh, no, I was going to.
Come on.
Just the easier minus one.
Yes. But that one can be simplified too.
Oh,
right?
no, I know, yeah.
Okay, I know.
I'm not.
If I don't harass you, I don't know who's gonna do it. I'll say fantastic. Oh, yeah, but then what about the beast I gave you?
Oh, it's over here.
Oh, okay.
Yeah.
Yeah, that looks good. It didn't back substitute, but it's just about right.
Yeah.
Yes.
Cool.
Yeah, beauty. What's going on, Claire? See that? Furrowed brow. Top row. See, it's just plain old e to the x, and literally that's just, you could be x up there, and so you can just, no substitution, just rock it. Don't think too deep. But no plus, okay, hold on, okay. Yeah, because it's a definite, so you don't need that. Does that make sense?
Okay.
So what's the antiderivative of e to the x? E to the x. Then put the line evaluated from, and then just do the limits. And then plug those in, subtract. You're good. That's it. You're welcome. Yeah?
Right.
Yes, now that. Oh, it almost looks good. It almost looks good. Wait. No, this, oh no,
Isn't that
this
the
is all,
power?
this is all wrong. This is good. I say up to here, I like it. The rest of it is just.
Natural.
I agree. Is the natural log of E?
No.
Why'd you write that?
I don't know. It's great.
That's all right. Now you're on like the math team, and so it's like. That's oh, okay. Oh, this is the next one. Okay, cool. So this one, beautiful, beautiful. Diego, I gotta check on you, man. How'd that first one go? Gorgeous, yeah. And then e to the 0 should be 1, so that's -1, yes, sir. But otherwise, perfect, perfect. Friends, how's it going? Yeah, where's that? How did you get that? So, it's the 1 over u. It's a natural log. Yep, there you go. There you go. Yes. Good, good. How we doing, Carly? Yes, this one. What's happening here? What's happening? Yeah, it is not. You're just kidding. Oh boy, look, you guys are jokers. So this is a natural log. So this is the 1 over u form right here. So let me put this up on the board because I think that the letters are freaking people out. These letters, these can be x's, and that's cool too. So like that integral, that second one is just log. Don't get thrown off because of the u's. This one here, this one was going really well. If someone was pressing you to keep simplifying. And then here, it's just that, from e to e cubed, so that's natural log of e cubed minus natural log of e to the first. What power do you have to raise e to get e cubed? 3. Natural log e is 1, 2. Yeah. I could easily see the exam writer putting such low-key things on the exam. If you can do this, I'd be very happy. Let's call it, my friends. So that's it. Thanks for all being here. Thanks for showing up today. I will no longer be putting on a show for you. So thanks for attending. I will be here on Wednesday and Friday, but I'm not dancing around. Allie, did you change your major?
No, not yet.
All right.
Still thinking about it.
Okay, good, all right. Good.
I haven't decided
Oh, yeah.
yet.
Okay, okay, fair enough. So I need to, so I think the basic thing is